Hello, hello! Welcome back. We are solving systems of linear equations, and today we're going to talk about a new way of solving called elimination. Well, elimination kind of sounds like eliminate, and essentially what we're doing is we're going to eliminate one of the variables and then solve for the other. So I have some steps by the questions. These are actually going to be more of steps today. My first step is, are my like terms in columns? Well, we can kind of pretend like we have these columns, and my x's are in a column, my y's are in a column, my equal signs, and then my numbers. So we have these columns, and I want to see, are my like terms in columns? Well, yeah, my x's are on top of my x's, my y's are with my y's, and my numbers with my numbers. So yes. Most of the time, we want our equations in standard form. So all of these are in standard form. And now question 2 says, do the coefficients of one variable cancel out? Well, that means I have additive inverses. And so if I look, my x's, they're not additive inverses, but my y's, I have a plus y and a minus y. Well, what happens if I have a positive 1 minus 1? They're going to cancel. So step 3 says add straight down. What I'm going to do is do a big addition sign right here and say 2x plus 4x gives me 6x. Y plus negative y, those cancel. So 6x equals 9 plus negative 15 gives me negative 6. Step 4 says solve for the remaining variable. All I have left is 6x equals negative 6. If I divide both sides by 6, I get that x equals negative 1. So this is step 1, solving for one of your variables. Eliminating one, solving for the other. So we just found that x equals negative 1. What I'm going to do is substitute that value into one of the equations and solve for the missing value. So I have, back to my pen, 2x plus y equals 9. That was my first equation from the last page. So I'm going to put negative 1 in for x, so 2 times negative 1, use your parentheses, plus y equals 9. Well, negative 2 plus y equals 9. Add 2 on both sides, and y equals 11. So I have x equals negative 1 and y equals 11. So my solution is the point negative 1, 11. Remember, our solutions are going to be points because they're where these two lines intersect. Well, now let me check, because I always want to check my solution. So I'm going to put 11 in for y and negative 1 in for x. 2 times negative 1 plus 11 equals 9. Negative 2 plus 11 equals 9. Does 9 equal 9? Yep. So I know without a shadow of a doubt that negative 111 is where these lines intersect. Okay, let's look at number 2. Number 2 says 4x minus 2y equals 10 and negative 4x plus 6y equals 14. I want to check, are my terms in columns? Yep, they're all in standard form. We always want them to be in standard form. Now let me see, do one of my variables, do they have coefficients that cancel each other out? Well, if I look, I have 4x and negative 4x. My x's are going to cancel each other out when I add straight down. 4x minus 4x gives me 0x, or they cancel. Negative 2y plus 6y gives me 4y equals 24. We'll divide both sides by 4. and y equals 6. So I just solved for one of my variables. Now using that, I'm going to substitute this, y equals 6, into one of my equations. Well, let me choose equation 1. It doesn't matter which one you choose. I have 4x minus 2y, but instead of a y, I'm going to put a 6 in there, equals 10. So 4x minus 12 equals 10. Add 12 to both sides, and 4x equals 22. Divide both sides by 4, and you get that x equals 5.5. You can leave it as a decimal, or you can change that to 11/2. Either one I'll be okay with. So this is what x equals, and this is what y equals. So my solution is 11/2, 6, or 5.5, 6. That's the point that these lines intersect at. Well, some of you guys are thinking, Miss Sawyer, we got a decimal. Do we like I don't know. I got a fraction. I got a decimal. Feeling a little iffy. Well, let's check and see if it works. If I check it using equation 2 this time, we used equation 1 last time, I get -4.